from 300 Kelvin to 400 Kelvin it has been given. Okay, and the temperature of 13.5 gram of aluminium and specific heat of aluminium is 0.9 joule. Okay, degrees Celsius inverse gram inverse. So calculate the calculate the calculate the amount of the heat required. Okay, calculate the amount of heat required. Okay, calculate the amount of heat required to raise the temperature. Okay, to raise the temperature. Okay, to raise the temperature. Okay, to raise the temperature of 13.5 gram. Okay, 13.5 gram. Okay, just our next slide. We are moving to the next slide. Okay, 13.5 gram of aluminium. Okay, 13.5 gram of aluminium from 300 Kelvin to from 300 Kelvin to that will be the 400 Kelvin. Okay, 300 Kelvin to 400 Kelvin, and the specific heat of aluminium it is given that 0.9 joule. Specific heat, you know, latent heat and the specific heat. Whenever the temperature it is being changes, then that we get the specific heat, and only the phase changes, that will be the latent heat we found. That's why here 300 Kelvin to 400 Kelvin temperature changes, that's why we get the specific heat. Okay, and the specific heat value it is been given, how much it is? Specific heat it is given value, it is 0.9 joule. Okay, that is the 0.9 joule value, it is the specific heat value, it is given 0.9 joule. So next we are moving to the next actually the chapter, that is how to solve. So that will perform the Q equal to MC del T. Okay, this is the formula MC del T. So M it is how much it is given, it actually the amount 13.5 gram. Okay, 13.5 gram, and then the M, this is the C value, how much it is given, point actually the 9. Okay, there will latent heat, and the mass it is given T. Again the specific heat value it is given, and temperature changes from how much to how much it is, 400 to 300 Kelvin, that will be the 100 Kelvin. So how much it will get altered that? Next it will be get 1215 joule, that is the amount we will get. Okay, that is the amount of Q, that will be MC actually the del T, 13.5 to 0.9, 1215 joule, that is the amount, that is the heat required to change the temperature of from that will be the 400 to 300 Kelvin. Okay, clear? Next we are moving to the next question hour. Okay, very important question also. From that question we'll describe about the CP and CV range. Okay, CP and CV range we can describe like this way also. Like calculate the enthalpy change where the standard heat of formation for the gaseous NH3 is even at 298 Kelvin, direction given as half of N2. Okay, that is the half of N2 plus 3/2 H2, 3/2 H2. Okay, and that will be the NH3. Okay, that will be half of N2 plus 3/2 H2, and that will be the NH3, that will be the gas. Okay, that will be the gas. So that will be the how much that way, how much you can, how that way you will have the chance to that calculate that kind of condition. Okay, so here how much it will, how you will that conclude that we got that del H. Okay, that will be del H, regular del H of actually the product minus del H of that will be the reactant. Okay, that will be the reactant. Del H of product, how much it will be given here. For the ammonia it is minus 11.02. Okay, 11.02, and minus for the actually the N2 plus H2. Okay, N2 plus H2, there will be no formation. Whenever any kind of formation it is value is not given, it will be taken as 0. So that will be the 0 only. So that will be minus 11.2. Okay, so there will be a formation, that amount, how much amount of energy, the standard formation of element in its reactant is taken as 0, therefore that taken as 0. Okay, there will be minus 11.2. That means the enthalpy change is equal to the formation of ammonia gas. That will be the equal. Okay, that will be the equal. This is a basic thermodynamics question. Okay, basic thermodynamics questions, like we already actually other did in different other reactions. Like if you have to count another kind of questions also maybe come from the like chlorine bond given. Okay, like enthalpy change, very important for the CH4 plus that Cl2 and then CH3 and then CH3Cl plus HCl. Okay, for here it is everything value it is given, like CH value it is given 412 joule it is given. Okay, then the CCl value, how much it is given, that 338. Okay, 338 value it is given. And then actually the next value also CCl, then CL value how much it will be also given, like how much it is given, 242 kilojoule per mole. And then HCl value it is given, and then HCl value it is given, and then 431. So everything it is been given. So next just we have to count at the value. Okay, del H. Okay, del H, that will standard del H chance. Okay, del H standard the del H of okay, del H of other the product. Okay, del H of product minus del H of actually the reactant. Okay, that will be the reactant. Okay, so ultimately how much it will be found, like 1115. Okay, 1115 kilojoule per mole. Okay, 1115 kilojoule per mole ultimately that is the quantity that is being found. Okay, like Hess's law or any other way, you can just think, you can just differentiate the value and you will get all the okay, there is no derivation required. Okay, like derivation you will forget, like just simple reaction, like already we have discussed about all the important formulas. Okay, like these were not being so much del H system. Okay, so ultimately the final, that will be the question come from that Gibbs free. Okay, that will be del G equal to del H minus T del S. Okay, del G. So here the derivative sense it has become del Z equal to del H, del G plus del H plus T, differentiation of the del Z with respect to the differentiate product of that T. Okay, with respect to the product we have already discussed. Okay, and then del S Ln reaction also we have discussed also. Okay, so there I am concluding here lecture.